Okay class, let's do a second example. Solve x squared d square y dx square minus 2x dy dx minus 4y equal to x square plus ln x. Okay, so now you know this is Euler equation because you have a coefficient in term of variable. So to solve this Euler equation, the first thing we need to do is to change or to transform it to become a general form of our second order ODE. Okay, so let me rewrite this equation. We have here x squared d square y over dx square minus 2x dy over dx minus 4y equal to x square plus ln x. Okay, so now we need to know what is the value of a, b and c. So you can see here the value of a is 1, the value of b is negative 2, and the value of c is negative 4. Okay, so we have a equal to 1, b equal to negative 2, and c equal to negative 4. Okay, we put inside our formula of general form for Euler equation. So we have a times d square y dt square. So we have 1 times d square y dt square plus b minus a, so your b is negative 2, minus with 1 dy dt plus with c times y, so your c is negative 4 times y is negative 4y. Okay, so we have negative 4y here equal to, for the right hand side, don't forget to replace all x with exponent t. So we will have exponent t power of 2 plus ln exponent t. Okay, so now let's expand this equation. You will have 1 times d square y dt square is d square y dt square, minus 2 minus 1 is minus 3 dy dt, minus with 4y equal to exponent 2t plus with t, because ln and exponent can be eliminated. Okay, so now you can see this one is the general form of our second order ODE. So we can choose any method to solve these differential equations. But then if you see, now we have a non-homogeneous second order differential equation because our fx is not equal to 0. So this is our fx. So now this one is the non-homogeneous. So let's choose to use undetermined coefficient method. But before that, we need to find the general solution for the homogeneous part here. Okay, so we have the homogeneous part, d square y dt square minus 3 dy dt minus 4y equal to 0. Okay, so we write the characteristic equation for this for this differential equation. So we will have lambda square minus 3 lambda minus 4 equal to 0. Okay, so for this characteristic equation, you will have the value of a is equal to 1, the value of b is equal to negative 3, and the value of c is equal to negative 4. Let's check for which case the quadratic equation is. So b square minus 4ac, we will have negative 3 square minus 4 times a times with c. Okay, so we will have 9 plus with 16 equal to 25. So it's greater than 0 means it's false in case number 1. Okay, so you will have a 2 distinct real root where lambda 1 and lambda 2 is not equal. So you can choose to factorize this quadratic equation whether by using calculator or manually, but you will have a value of lambda is equal to lambda 1 is equal to 4, and you will have the lambda 2 is equal to negative 1. So for this case, the general equation will be yc equal to a exponent 4t plus b exponent negative t. Why we use t? Because now our equation in term of dy dt. Okay, in term of dy dt. So all x is equal to t now. Okay, so we have done with the general part or the homogeneous part. Now